All right, you guys, welcome to this lesson on classification of matter. You guys look, so really pretty much all the stuff in the universe, matter. Now there's actually two things that the universe is made up of, matter and, you guessed it, energy. But we're focusing on matter, okay? And then you can break up matter into two main categories. I wouldn't expect you guys to know what those are. Here they are. So hopefully you guys just copied this little flow chart down. So matter can either be a pure substance or a mixture. Now I'm hoping you guys would pause it, here shortly when I ask. You guys can see, I don't know if you guys can tell the brackets here, the pure substances can break off into one of two categories. So matter could either be pure what or pure what? You guys know what that is? Pure what or pure what? And there it is. Matter could either be a pure element or a pure compound. Okay, so we kind of want to just look at what those are. Here's an example of a pure element. I don't know if you guys can see it, but this is showing like a picture of pipes. And you guys think about a lot of your water pipes in your apartment or your home behind the wall. What do you guys think they're made of? You guessed it, copper. So what this is showing here is just copper atoms. How you would recognize an element, now when you guys are in the classroom, and also you guys should have one readily available for yourselves, is a periodic table. If you can see that element on the periodic table, that would be a pure element, okay? So basically, this just has one type of atom, copper atoms, and there's certain characteristic that makes a copper atom, we'll learn that later. So something could be a pure element. Now a compound, what is a compound? I think maybe some of you guys are thinking compound, you think about just how it sounds like things coming together. That's what a compound is. It's two or more atoms, types of atoms chemically bound together. Now if you guys look, so here's an example of a compound. Now it's in a bowl, you're probably, I'd ask you, okay, what is that? It might look like milk to you. In actuality, it's sugar, right? So it's just, you guys know sugar is a white crystalline solid, okay? So sugar would be an example of a compound. Now look at the molecular structure compared to this. If you notice in this one with copper, it all has just the same type of atoms, copper atoms. But here you can notice that there's white, black, and red atoms. And you guys remember what I was saying? Sugar, you guys remember like paper is an organic compound. Organic compounds always have carbon in it. In fact, that's what the black atoms are. And a lot of organic compounds also have oxygen and hydrogen. And the red is the oxygen atoms, and then the white are the hydrogen atoms. So you can see two or more different types of atoms chemically bound together. This would be an example of a sugar molecule. And obviously there's trillions and trillions and trillions of sugar molecules here, just like there's trillions and trillions of copper atoms here. But that would be an example of a pure compound. The reason why they're called pure is because that's all it contains. This sample of matter here, all it contains are sugar molecules. This sample of copper here, all it contains is copper atoms. That's why they're called pure elements or compounds. The other type of matter are mixtures. Mixtures, and there's two types of mixtures. You have what are called homogeneous mixture, and you have what's called a heterogeneous mixture. Just to kind of help you break it down, you think about it, that's like kind of a big word maybe you've never heard before, homogeneous. Well, you kind of break it down. Maybe genius, I don't know what that is, but homo, you're like homo, what about, oh, homo, like homosexual. What's homosexual? Boy, boy, girl, girl, right? So what do you think homo means? It means the same. So a homogeneous mixture is a mixture in which the consistency is the same throughout. So we'll see an example. And I don't know if you guys can see, what do you guys think that this might, a sample of this might be? You guessed it. That would be, you know what? For sake of, I'm going to say it's tea. No, you know what? Because I'm going to show something. I'm going to say it's tea. Okay, so it's tea. So, you guys, why is it called a homogeneous mixture? Well, you guys think about it. It's homogeneous because it's the same throughout. You guys, if you were drinking your tea, would you expect it to taste different here than it would down here? No, it's mixed evenly. So obviously the main component of tea is, you guys see these Mickey Mouse molecules? Those are water molecules, H2O, C2 hydrogen, 1 oxygen. So it's got water, that's primary. And then you guys think about, apart from water, what's probably the next biggest ingredient with the tea that you guys buy in the store? It's probably sugar, right? They put a bunch of sugar in. Here's that sugar. You guys notice that's the same type of molecule here. It's got sugar molecules in there, right? Because that's what makes the tea taste better. And then you got this molecule here. Either that could be the actual tea molecule that makes TT, or it could be, you guys know what's often in a lot of tea is caffeine. So this could be most likely it's a caffeine molecule. Okay, it's not that important. But you guys see why it's called a mixture? Because there's several different types of substances within this sample of matter, as opposed to these ones which were pure and they only have one type of substance. And then the last one is a heterogeneous mixture. Well, you think hetero, you guys, what does hetero sound like? You might recall heterosexual. What is heterosexual? Guy, girl, girl, guy, right? And what does hetero mean? It means different. So this would be where it's a mixture because it has two or more different substances in it, but they don't evenly mix. And you guys could probably guess what this is an example of. Yeah, duh. Oil and water, right? And so you have oil molecules here, and there's a reason why oil and water don't mix, and we're going to learn that in a few months. You guys are going to be able to explain the world around you guys. That's why chemistry is so awesome, is that, you know, it's a study of matter, and you'll be able to have a better understanding of matter and why things exist the way they do. So you have oil here and water here. So you guys, basically, there are four main categories of all matter. Either something's going to be a pure element, pure compound, a homogeneous mixture, or a heterogeneous mixture. You guys, I just want to do a little practice, so I'm hoping when we show these, you guys try to figure it out on your own. So, try to figure out which one of the four categories do you think you'd put this in. Here's a flask full of sulfur. Sulfur. I'm only going to give you guys a few seconds. You guys, sulfur is a pure element. You know how you would confirm that? If you guys look on a periodic table, I'm looking at the periodic table in my room, you'll see sulfur. It's number 16. This just has sulfur atoms. It's a pure element. Okay, let's go with this one. How about I got some salt? Salt. What do you think salt would be? Which category? Which category? You guessed it. It is a compound. Most of you guys know salt is sodium chloride. So it's got two or more atoms. And all that's in here is salt. So it's not a mixture. It's a pure substance. But it's not a element. It's not like you're going to look on the periodic table and see the element salt. Come on now. It's actually a combination of sodium and chlorine, NaCl, sodium chloride. Okay, so that's a compound. Let's go with, okay, we'll go with this. We'll go with soda. Little advertisement there. I'm not getting paid by Pepsi. I don't have enough subscribers. Okay, what do you guys think? You guessed it. That's a homogeneous mixture. Because you guys know, what does soda have? Obviously, first of all, first number ingredient, if you guys look on the ingredients, it's always in order of the amount by mass. It's going to be water. Then the next one is going to be sugar. It's actually a high fructose corn syrup, and that's like essentially sugar. Then you're going to have some other things, colors, caffeine, and then what makes it kind of lighter, you guys know what makes soda is carbon dioxide. They pump carbon dioxide gas in it, right? That's what makes it fizzy. But anyways, you guys get it. It's a mixture, okay? Let's go with this one. You guys better get this one. Come on now. Ooh. You're getting sleepy, very sleepy. Okay, what is this? You guessed it. That would be a homogeneous mixture. In actuality, you guys, what do you think this is? Once again, it's pretty much just what I want. It's oil and water. And here I just got an oil here with some blue coloring that's soluble in oil, and then over water, and so we get that trippy effect. Okay. What about this? This square here. Now, I'm not going to tell you anything about it, but you just try to think, okay? It's a metal, okay? What do you think it might be? You know what, this one could be a different one. You know what, but this is just a pure aluminum, and aluminum is a element on the periodic table. It is a pure element. But you guys know, most of your metals that you guys encounter, you guys know what they are? Most of the metals, like your bike and all that, you know what they are? They're actually homogeneous mixtures. You guys, you know what you call a metallic mixture? You call it an alloy. Most of the metals you have are alloys. They'll have iron and then some other things to either make it non-rusting, right? To have it stainless, they'll add some chromium in it and maybe some nickel. And they'll add some other different metals to maybe titanium to make it stronger, aluminum to make it lighter. So there's different properties there. This one's a tough one. See if you guys can get this. Baking soda. Most of you guys have that in your refrigerator at home. Baking soda. Which one do you guys think that would be? I could totally see if you messed this one up. I probably would if I was sitting in a chemistry class back when I was 15 and someone asked me that. I wouldn't be surprised if some of you guys said it was a mixture. It's actually a compound. And I don't know if you guys have ever looked at a baking soda box. It's going to tell you what it is. It's number one ingredient. It's sodium bicarbonate. It's got sodium bicarbonate is NaHCl3. Don't worry about that. But it's got a bunch of atoms bound together. But all this contains is sodium bicarbonate molecules. So it's pure, but it's a compound because it doesn't just have one type of atom. That one's a tough one. This one you guys better get. Come on, sugar. Man, if you guys don't get this, woo, you were out of it, because duh, we got sugar right here. Okay, that's a compound. You guys, right? It's got different atoms chemically bound together, but all it contains is sugar. Last one, see if you guys can get this one. Mineral oil, okay? You can use this, I think, right? It's kind of like parents use for their little babies and stuff like that. I'm trying to think of what else you use mineral oil for. I don't know, I don't know. Okay, that was kind of creepy. But anyways, mineral oil. What do you guys think that might be? Well, you know what? I'll say this. The fact that I look on the ingredients and I only see one ingredient, what does that probably tell you? It's got to be a pure substance. And you guys know mineral oil is not going to be on the periodic table. It's not like you see number 87 is mineral oil. You know, it's a oil. It's actually a compound. And much like all other organic compounds, it contains a bunch of carbons, hydrogens, oxygens in a certain ratio. This would be a compound. All right, guys. Good stuff. We'll see you guys next time. Bye.